Hello, I am Cadet Lieutenant Junior Gray Pomatz, the SeaPerch Commander, and we are Team Platinum from Chaparral High School, Temecula, California. This is our ROV. It's called the USS Ballin. Our purpose of the ROV is to make it as quick and maneuverable as possible. We all thought about a design and put our ideas together to create our ROV. Our construction officer and electrical officer will go more in depth about it.
Hello, I am Eileen Panyawa, and I am the Construction Officer for Chaparral Team Platinum. As Construction Officer, my job was to assist my other team members in the overall design and construction process of the ROV. We all worked together to brainstorm an idea of what kind of ROV look would give us speed and agility, but at the same time be able to withstand weighted tools and move different objects in the pool around. We decided on utilizing PVC pipe as the main medium of the body of the ROV, since it would be sturdy enough to hold the motors when we attached them to the side in the middle of the ROV. The pipes being hollow allowed us to drill holes into them to allow water into the ROV, allowing us to achieve close to a neutral buoyancy when in the water. We also decided to paint our ROV such a startling pink because the pink would greatly contrast the white of the mission course and the obstacle courses. It would also give us better visibility of the ROV while under the water, so that if there were any distortions in the water, maybe rain or a diver moving and creating waves and ripples on the surface of the water, those variables wouldn't hinder us as much as they would have if we decided to go with the plain white PVC. We also added a hook onto the design, since there would be tools, levers, or different objects that needed to be pushed or moved around while in the water. The overall scale of the ROV was divided in half from the standard stock design, so the smaller frame would overall reduce the weight of the ROV, giving us better speed, while also giving us more room to fit through the rings of the obstacle courses.
For me, as an electronics and soldering officer, I had to make sure all the electronics, such as the motors, the controller, and the wiring for the ROV were in good use. When it came to building the electronics for the ROV, there weren't any problems that happened so forth. For the controller, it was already pre-built by us as an extra and was in good use, meaning I didn't have to create another one. For the motors, I wrapped electrical tape around the motors and encased it in wax in the container to keep water from getting into it. When it came to soldering the wires, I wrapped the copper wire around the loops of the motor and soldered it to keep it stuck onto it. Afterwards, I used Gorilla Glue to attach the propellers onto the motor so it wouldn't come off. Overall, when testing, no discrepancies were found, and it was perfect in the water.
As for the buoyancy, we used trial and error to get the pool noodles just right. We threw it into the pool without any motors running to see how it would float or sink. We would cut little by little until it would float and sink to our liking. With that, our ROV is made by a series of trial and error from our past experience with SeaPerch as well. A lot of thought went behind our design, and with hard work and determination, our ROV worked well under the water.